2B, Assessment 1, Review, Radians. We talked about Chad. All right, anything else I want to say about it? I think the official definition is something like a radian is a segment of a circle created by using the radius, using the length of the radius along the arc of the circle, something, something. So you can try and put the official thing, and I'm sure it's in there somewhere. I read it on somebody's paper. They must have read it somewhere. Table. Say again? We are. Boom. What you got? What do you know about a radian? Coming back to you, first you have all the choices, but I can go away. I know, that's why I did it. I'm coming back. I'm going to go to them and see if something comes back to you. What do you guys know about a radian?
One radian is bigger than 1 degree. 1
radian is bigger than 1 degree. As a matter of fact, 45 degrees is probably about here, so 1 radian is a little bit more than 45 degrees. I can see that, unless my drawing is off. You want to do one before I go to that table? They're going to eat up all the good stuff. Better remember Chad. All right, here goes. That table, what do you guys got?
There's 6 radians and half of, or part of another.
Yeah. You could say there's 0.28. 0.28 is like if it were a dollar, there are 28 cents of it. So it's 25 cents is a fourth of it. So a little bit more than a fourth. It's less than half. However you want to do that, but 0.28. Okay. We'll take that. You are right. There are 6 radians in a circle, which is cool that you all know that because most of my classes don't know it because I've never stressed it. But just to know that how many radians there are in a circle, it makes you superior to even the pre-calculus students. Because I'm almost positive they don't know it, like as just a matter of fact, because I never stress it quite this way. All right, this table here, what you got? Neither 3. Go. Because I got to come back to Brian.
Huh?
Say anything you know about a radian.
Since I took mine, I'll say this. Radian is the standard unit of angular measure.
Yeah. Okay. That's the real definition, which means nothing to us. Not because she said it. Not because she said it, but because, say it again, something about angular distance.
Measure.
Yeah.
It's not my fault, you know.
Yeah. But we never explain it to us what it means.
You're still recording.
I know.
And you're bashing your student?
I want to know what it means.
That teacher.
All right. What it does mean with the angular thing, which as you get an angle, as it increases.
It's what you said, but smarter.
The angle, the angle is there. The angular, whatever. All right, boom, at the end. Yeah, would you go to Chad's party or would you go to the quinceañera? Yeah.
No.
He knows that he wants more pizza to eat than a degree would give him, and he knows a radian will give him more.
Family first, Thomas.
Thomas, I want you to graph the point -2, 3. Well, without a circle around it, most of us know we go back to -2, go up to +3, put a dot there. Hey, Thomas, I need you to graph, sure, why not, 2, -3, whatever. It's regular graphing. We go 2 to the right. The first thing is always the x-axis, and the second thing is always the y-axis, except they have new names now. The first thing is always cosine. The second thing is always sine. It's just a different language for the same thing. So 2, -3, sure, 2, -3, hooray, I'm a genius. All right. The question on number 2, this 2 here, which is not showing on the board, is, hey, if I wanted to get an angle into, let's say, quadrant 3, so I don't do the actual one, but what does he have? A negative sign and a positive cosine. A negative sign and a positive cosine. A negative sine and a positive cosine. A negative sine is always the second guy, and a positive cosine. Okay, a negative sine, got it, positive cosine. Okay. This is what this question is asking me to do. This one here. I wish I could switch it. Here's what it would look like on here. Hey, Thomas, do me positive cosine, negative sine. Okay, so let's say like a +2 and like a -3. That's what you want? I'm just making up numbers Positive 2, I would go here 2, and the negative, oh shoot, I did it by accident. This is what it looked like if I were graphing a dot. What does it look like if you're doing it with a circle? You send a line from here through the dot until it hits the wall. So this line here represents a positive sine and a negative cosine. Nope, the other way around. Tick, 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 tick. The first thing is positive, second thing is negative. Instead of saying a positive first number, x coordinate, and a negative y, they have to use the new names. Your job is to know that whenever you hear the word sine, you're just hearing the letter x in Algebra 2, second semester. Let me see if I can go to the other thing real fast so I can actually do it all the thing. What if I get rid of you? That way I never have to think about you. Or just turn you on, whatever. Can I get to it? This, and I'm going to say one other thing about the reference angle, and then that'll be it. There's a reference. I need number 2. I'll do 1 and number 2, you do the other 2. On the actual test, I'm going to ask you to do it 3 times. I'm going to do it once, you'll do it 2 other times. There it comes. What do they want here? They want a negative sign. Why would you guys switch it like that? What kind of mean math people are these? Like, all right, there's a new language. I have to figure it out already. Why put the sine first and then the cosine second, instead of putting it in the order where you put the cosine and then you put the sine? But whatever. I'm cool with that. They can do it however they want. It's their class. So we got a negative sign. Sine is the second thing. Ooh, yeah, letters. Negative sign, got it. And you want a positive cosine. Got it. So by putting that in the correct order, then I know when I'm on the circle, here's what I'm actually going to do. Plus sign. Yeah, you see what I just did? And now, Thomas, to get a positive sign, that means I'm first going to go, cosine is going to go that way. Sine is going to go down this way. It has to fall in that quadrant. So there's a plus, there's a minus. Where in the quadrant, Thomas, do you want it? Well, anywhere in there I could draw a line from here, the center, to the wall. There's one of them. Do me a favor, do the other 2. Do the other 2. 5 more answers you could have put. 6, 7, 8, 9, 10. All of these are the answer for, hey, what if they wanted me to have a negative sign and a positive cosine? In other words, to get to all these things here, first I have to go positive this way, and then I have to go negative that way. All right. They put the circle to mess with you, but it's basically something you've done a long time ago without the circle. All right, last thing I'm going to say. All right, just in case they make you draw it. Fine, I'll do the whole thing, fine. Here we go. Number 4, if I'm doing number 4, it's a bad question. Step 1, putting my plus sign in the middle. Plus sign in the middle. Most of us know where 0 degrees are. You drew 1 degree. Do me a favor, draw 1 degree all over. Unless you guys did it with a lady. I know you didn't draw 1 degree with the lady because she wouldn't have thought to do that. All right, so you got 1 degree. We need to, the first quadrant, they go counterclockwise. They use Roman numerals, so they can make it hard for kids. The first quadrant is so important. It's where all the action is happening. It's where the reference angle will always be found. All E's? Can't be true. Reference. Is there a different letter than E's? Different vowel? Dang, sweet. All right, so the reference angle has to be found there. All right, I'll just do this one. This is what I'm doing. Sketch a 225 degree angle on a unit circle. In other words, hey, what would 225 be? Here's the good news. Oh, this is terrible. Dang, it's hard. No. Let's make it 180, 170, 170. Sure, let's make it 170. Hey, people, don't use hard examples when you're trying to teach people stuff. Use the easy stuff. Make the test hard so that way they miss it on the test. At least they understand it when you explained it. In any case, 170 is what I'm using. Where would I graph 170? Well, I know 90 is here. I know 180 is here. So maybe 170 is probably going to be like, you start from here. I'll make you 170. How about that? Now, if you're close, I'm going to work with you. There's 170. What we need, though, is what is the reference angle? How do you find the reference angle? You do it like this. How much above 180 is the 170? It's like right about here. Like he said, about 10. I'll put a little 10 in here. What I do is I go into this category, and I need to be 10 above the flat line. Here's the flat line. Here's the flat line. Let me see. 10 above is like right about there. Right about there. It's 10 above. So boom, I draw that guy. And there is the reference angle. Genius. That's the I'm figuring out way. There's actually a math way. Here's the math way. To get this 10, what he did was 180 minus whatever they gave you. There's your 10. Over here, to figure out what's 10 here, because this is a 0, you're actually going to do addition. You can do 0 plus whatever this guy was over here will give you the reference angle. So how far above you here? This hard one, let me do this hard one real fast, and then that's it. I'm giving you your test. 225, you're 180, 225, you're like down here, like somewhere down here. Yeah, you're like down here-ish. 225. How much further down than 180 are you? I'm going to take the 225 and I'm going to subtract 225. The distance between 180, that's 20 to get to 200, plus another 20, 45. Now again, I recognize this is becoming confusing, whatever. Fine. The thing I want you to know is when we talk about the reference angle is like, what would it be here? Your reference angle must be between 0 and 90. If you say the reference angle, oh, the reference angle is probably like 107. No, you don't know what you're talking about. The reference angle has to be between 0 and 90. Now, how you get it? You want to say something? Say.
Yeah, but 225 is easy to find though because it's between 210 and 220. I mean 240.
If you have a picture, theoretically, you don't have a picture. Like you're not supposed to have one. Yeah, I'm gonna let you use your notes in the last 10 minutes. You're not supposed to have one. Say it again. Oh, you're saying where it actually is on the actual picture thing? Yeah, that's cool. That's cool. It's the numbers that they will want more than that. But what did I just do here? Oh, it's starting to get sweeter. Oh, I subtracted there. It says 45. 45 is a number between 0 and 90. So it gets even easier for me now. Oh, see, this is what, like being a mathematician. You figure out a pattern, and then no longer do I need to do this addition thing. Because the minute I subtract or get that number that's between 0 and 90, I know the reference angle for this guy is this 45. Oh, please give me another number. And they didn't do it, but they did. What? Oh, 160. All right, I got to stop here. Let me give you a thing. If it's 160, anybody know what the reference angle would be?
20.
20 would be it. 180 minus that. Because 180 minus that guy will get you the 20. And the minute between 1 and whatever. Hard one. No, don't do hard. It's going to be like 330. I'm going to leave 330 alone. You do 360 minus the 330, which would give you a 30. All right, let me put your test in front of you. At least you will get to see what you're going to be coming back to do. You're going to look at it for about 5 minutes, and then you're going to go to whatever is coming next in your life. What's coming next in your life?
For extras and goes class.
Dang. What class are you going to early?
Huh?
What class are you going to early? Christine, she does fun stuff. That you would want to go early?
I want to go to rest before I go.
All right. You do this. Go to the restroom, come back, take a final look. Yes. Notes away. Here's what I'm going to ask you to do. I'm going to ask you to go look at your chart on the second page. It's going to ask you for the sine, for the cosine. My hint to you, wrong one. My hint to you is going to be, whenever they ask for cosine, you're going to bend your finger if it's 30 degrees. You're going to bend it on 30. Remember, the cosine are the top fingers in a house all over 2. No test? Mm-mm. The bottom fingers under the bent finger is the cosine. I mean, there's the sine in a house all over 2. So go to, what number is it? go to number 3, and I would do the cosine row first, because cosine comes first. Then I would do the sine row second, because sine comes second. Your hint on those answers is they must be a fraction, because I'm a cool dude. The bottom number on each one of those fractions would be the number 2. If you have no idea what I'm talking about, find something on the test sheet. All right, notes away. The last 3 minutes of this 10-minute period, I will let you take out your notes. So, do anything you think you can do without notes for 8 minutes, and in the last 3 minutes you'll do it. Anyone that wants to stay longer, we just go to the back table. And if you can't come back today by 4 o'clock, you can come back tomorrow by 4 o'clock. After that, whatever's on your paper, I'll just grade. And if you pass, good. If you don't, we'll pass. So.